We have discussed in our previous video that Democritus was the first man who proposed that matter is made up of many tiny particles, and he named these particles atomos, meaning indivisible. This was Democritus' atomic theory, and it was rejected, for they had very limited information on this theory, and had a lack of technological instruments back then. Almost after 2,000 years, in 1808, John Dalton postulated the famous Dalton's atomic theory based on his scientific work. Democritus and Dalton have similar ideas about the atom. Dalton's atomic theory states that all matter is made up of many tiny particles, and those particles are atoms. With this postulate, he means that every form of matter in this universe is made up of atoms at its fundamental level. The second statement that Dalton made on atoms was that all atoms of the same element are alike, and they are similar in chemical property and mass, but differ from the atoms of other elements. Let us try to understand this statement with the help of an example. In our example, we will take two elements to say these elements are the element of oxygen and the element of iron. Now by first postulate we have come to know that these elements of oxygen and iron are made up of many tiny atoms. So all the individual atoms present in the element of oxygen will have the same mass as each other, and every atom present in an element of oxygen will have the same chemical property as one another. So we can say that all the atoms present in an oxygen element are alike. Similarly, the individual atoms present in an iron element will be the same as one another in terms of their mass and chemical property. Also the second postulate states, but the atom present in an oxygen element will be different from the atom that is present in an iron element in terms of its mass and chemical property. So with the help of the second postulate we can say that all atoms of the same element are alike, and they are similar in chemical property and mass, but differ from the atoms of other elements. The third postulate Dalton made on atom was that atoms can neither be created nor destroyed in the process of chemical reaction. To understand the third postulate we will take the example of a water molecule. We know that a water molecule is represented as H2O in the molecular formula, where H stand for hydrogen element and O stand for oxygen element. The subscript in a compound represents the number of the atom for that particular element. So, to obtain a single unit of water molecule we need 2 hydrogen atoms and 1 oxygen atom. In total a single unit of the water molecule has 3 atoms combined. We can see that in this process of chemical reaction no extra atoms are created. Neither the number of the atom are destroyed. That is, we add up 2 atoms of hydrogen element and 1 atom of oxygen element, and obtain 3 atoms in a single unit of a water molecule. So, with the help of a third postulated we can say that atom can neither be created nor destroyed in the process of a chemical reaction. The fourth postulate of Dalton on an atom was that atoms of different elements may combine with each other in fixed, simple, whole number ratios to form compound atoms. Understand this statement. We again take an example of a water molecule. We can see that a single unit of the water molecule is always made up of a fixed number of atoms, that is, 2 atoms of hydrogen element and 1 atom of oxygen element. The same process of combination of atoms goes for the formation of every compound. If we are to again take example of other compound, say, this compound is carbon dioxide. If we observe well, we can see a single unit of carbon dioxide molecule is made up of one carbon element, and two oxygen elements. So, to form a carbon dioxide molecule we always need a fixed number of atoms, that is, one atom of carbon element, and two atom of oxygen element. Dalton also states that the combination of atoms is in the ratio of the whole numbers. This means that we can only combine the whole unit of atom element to form a compound. In the case of carbon dioxide molecule, one carbon element is combined with two oxygen elements. We can see the combination of atom is in the whole number. So according to Dalton every compound are formed in similar way. Therefore with the help of Dalton's fourth postulate, we came to know that atoms of different elements combine with each other in fixed, simple, whole number ratios to form compounds. Although Dalton's atomic theory was the first atomic theory to be accepted scientifically, his theory has some drawbacks. And, the structure of atom was later modified. To find out how the structure of the atom was modified, stay tuned to our channel and watch our next video. Until then, peace learn.